My data has been, I have a bunch of data, okay, containing house prices for maybe their sizes, their location, their amenities that are already there, the number of rooms, and then on my right side, I'm going to say this is now 10,000 per month. Then I'm going to have another one based on the same categories, the same things. Then I want to see it as maybe because it's a 5 bedroom. Then you're being told now this is 30,000 per month. Then you have a bunch of data, thousands and thousands of that kind of data. So you are able to predict a house price. So from this time around, I'm going to pass it to Val. I'm going to say, okay, this is a two-bedroom apartment. It has one, two, three, four amenities. It's a permanent. It's a whether it's a grower or not. Then I'm going to say it now. Predict for me the price of that particular type of house. Then tell me, oh, this is now 15,000 per month. How? Because it's able to learn from that particular huge amounts of data. Is that clear, Mr. Wilberforce? Give me a thumbs up kindly. All right. So there's an example of whether you can do that. Okay, another one is students either passing or fail. You see, we're able to do this by just writing a bunch of rules. If else, if else, if else. So we have those machine learning algorithms that can do what's called classification. So we have classification algorithms, prediction algorithms, and regression algorithms just under machine learning. So some common algorithms that are being used in supervised machine learning algorithms are linear regression, logistic regression, decision tree, random forest, SVM. Another one that are not here like this what's called random forest. Okay, random forest is now decision tree. We have an ensemble versions of decision trees that's form what's called a random forest, an ensemble algorithm. So we want to talk about a number of them. We want to write our own linear regression algorithm, logistic regression algorithm, decision tree, classifiers, a random forest, and support vector machines. Okay, don't worry about the terms. Everything will be clear. I'll tell you what's being applied, what's that algorithm, what's the mathematical intuition, and how it works. So you'll find which one do you use for what particular condition. When you do classification, which one should you use? When to do a prediction, which one should you use? Okay, so we'll be able to know that by the end of the day. Everything will be crystal clear. So let me take you through another one. It's what's called the unsupervised machine learning algorithm. Again, because of time, I'm going to go so fast so that by tomorrow we dive into the practical part of it. You will. I'm just going to explain what's there. Kwa haraka. Now you'll have time to just read them at your comfort when you already understand that. So just bear with me. I might be so fast, but don't worry about that. Uh, Now, unsupervised machine learning algorithm is where you use what's called unlabeled data. So it's the opposite of supervised machine learning algorithm. So with this one, you find hidden patterns from data that's unlabeled. What do you mean by labeling and unlabeling? I just explained this some few minutes ago. Could give tags. Could give tags. I have cows. I can say it's a calf. This is a melon. A melon is called what? A bull. Okay. This is a cow. I'm able to tag that based on their characteristics. So there's that pattern that you're able to identify. Okay. Maybe for a cow it's having an udder, for a calf it's small, for a bull it's having big horns, or it's having something. Your machine is able to predict that based on your characteristics you have defined. Now, where is this particular thing is used? So, okay, so it works based with unlabeled data and finds hidden patterns and structure on its own without your intervention or without your input. Also, input here, label. You have not labeled anything. Very interesting. Very interesting. Just pick up things clustered and structured, just throw it to that particular machine learning algorithm. It will be able to do what's called to be able to learn from that data. That's where you get things like customer segmentation. You are able to segment or group your customers based on a given criteria. For example, buyers. Those particular similar buyers. Okay, like okay, for those people who are in around Nairobi, they like buying appliances. For those people who are in Ushago, they like buying fertilizers. So I'm going to throw my data to my algorithm, random one, huge amount of data, is able to learn by its own. Hope that's clear to you, Mr. Dennis. Just by thumbs up. Okay. So there's no correct or wrong answers that are provided this particular algorithm. So a given use case is what's called customer segmentation or grouping. Another one is called anomaly detection. Anomaly detection, like fraudulent fraud. How do banks do this? No, this is now a fraudulent transaction without human being intervention. How is your bank or ATM machines able to notify, or even your apps, mobile apps, can able to flag you that this no, this is a fraudulent transaction, and you just quit whatever thing you're doing. So that's an example. It's called anomaly detection, like unusual bank transfers or bank transactions. Another one is what's called recommendation systems or recommendation engines. Very interesting. Very interesting. So we have what's called YouTube. For example, YouTube. You just watch random videos. Okay. You move to music. You move to movies. You move to politics. Anything randomly. Then all of a sudden you find out, oh, the next day is recommending you a lot of politics stuff, a lot of politics stuff. So how is it able to know that? How is the machine able to know that? So YouTube itself, it's just what's called a recommendation engine. Okay, that's what's called recommendation engine. That's able to do your recommendation based on similar things that you watch over and over again without your own intervention. So we have some particular algorithm that are being used there. We have what's called K-means clustering algorithms. Very interesting, I promise you. K-means clustering algorithm. I want to show you all the mathematical intuition, what it means, and how we want to write our own K-mean clustering algorithm. This will be able to cluster our own data or segment our own data. Then the next one is called hierarchical clustering based on hierarchy. Maybe you like watching politics so much, there's the first hierarchy. The second one like sports, the second hierarchy. So my machine learning is able to, my algorithm is able to recommend for me new videos based on my hierarchy. Then what's called PCA or dimensionality reduction. PCA means principal component analysis. PCA. Principal component analysis. You can tie it what's called dimensionality reduction. You will see that in just maybe from tomorrow you see that. And then we have another algorithm called db scan. Db scan, just scan that and able to label learn from your data. So that's an introduction about unsupervised machine learning, an overview. I hope you connect the dots. So the next one is on reinforcement learning. This one I told you earlier on. Okay, to the based on what's called penalties and rewards. So I myself, you can write a machine learning algorithm that's able to learn from your data through trial and error. Trial and error, trial and error. Like training a dog, essentially to training a dog or training a bird on how to communicate with it. What I just explained earlier on. You can say come, the dog will come. Why? You train it that every time you say come, every time you say come, you always throw a bone to it. Or you always carry that thing it's eating on. I don't know what it's called in English, where the dog eats at. So you can carry it, say come to normally no. For chicken, you can say for birds, maybe chicken or hens, I don't know how you call it. You can say every time you whistle, Every time, every occurrence you whistle, you throw seeds. Every time you whistle, you throw seeds. So birds, your birds will know, okay. So even when whether you are not having those seeds, you then whistle, your birds will come. I hope you normally do that, Mr. Wilberforce. How do you do yours by then? Which how do you call your chicken at home? Do you whistle or you knock sufurias? How exactly, yeah. So that's now an example of a reinforcement machine learning algorithm. Like calling a cat, how does this particular organism know if say it will normally come? Maybe when it's so slick and a small cute cat tiny, every time say you put milk close, you throw mena, you throw a piece of ugali or something else. You say, so okay, it will notice. Every time I hear it will just come to eat. So that's an example how you can do machine learning. This also applies to computers anyway. Computers are just naive. Actually, they're not smart as that, they're just naive. Everything give it, learn from that and give the output. So what the task on is to define whatever thing you want to do. An example is playing games. Mobile phones are having playing games. Okay. I know in your youth you used to you have some particular fun game. Maybe now because of work environment you won't find that time to play. But by then, when you are youth or somewhere when you are still a kid, you had that particular game, your admirable game you used to play so much. So for nowadays, you can play against a computer. Like this, you're doing what's called is it PS4, PS something. The mobile phone they used to play football or pool billboards. You can play against the computer, and this computer will normally even beat you. You can either beat it or beat you. Why? Because the data has been trained on how that game is being played. Take it back to 1948. Back then, where do what's called an AlphaGo. Okay, so the AlphaGo beat the famous chess player Garry Kasparov. Okay, to was able to win that particular game. A world champion playing chess, so it was able to do to win that. So we have what's called chess engines, AlphaGo, another one was called the Turing machine back then. So those are now mechanical computers defined with that. Another instance is in robot navigation and control. That's clear. Autonomous driving systems, like driving cars. Driving cars. How are these people able to come up with driving cars? You're going to give it a bunch of data. This is a tree, don't knock it. This is a house, don't knock it. This is a human being, stop. This is a road. This is a red light, say stop. Green light, move. You would train a bunch of data. Then you give you what's called rewards and penalties. So maybe your reward is whenever you see a green light, the engine will just go off automatically. That's a reward because someone might be passing. So rewards is something like positive. If that's correct, you say that's tick, okay? Like giving a dog a bone, that's a reward. When it's come, very positive. Say come, it comes. They say give it a reward, a bone, throw it for it a bone. That's called rewards and penalty. So some of the algorithms are the Q learning, deep. Okay, we'll be using what's called neural networks for this particular matter. We see deep Q networks, policy gradients. We want to talk about some deep learning algorithms like RNN, CNN, those ones, convolutional neural networks and recurrent neural networks. Don't worry about now, they might sound weird, but we'll see that in details. So this now a summary of what we've talked about. I'm not going to talk about that. It's everything you've just discussed. So that's all about the three. Any question or comment from any of us kindly before I move to the next one. Hello, Mr. Deans. Are you okay? You have a question? By thumbs up. Okay. I'm telling a lot of stories, by the way. I hope you're enjoying my stories. Hello, Mr. Wilberforce. Sawa sawa. So just listen, just get the volume. There's someone I'm heading you. There's someone I'm taking you through. Kuna mali na direct. Just get to understand what's happening there. Now, we want to move to the current era, where what's called generative AI. That's where we are. Chat GPT, DeepSeek, Cloud AI, Gemini. In the latest Google I/O just a few days ago, they launched a bunch of AI application like the ask ask me in Google, a Google Map. Ask Google Map. So just click on that. You're able to ask it a bunch of complex scenarios. Then it tell you what to do. Maybe tell the nearest coffee shop brewing the best coffee in the entire city. So just give you the direction to that particular Java coffee house. You can ask it a complex question. So that's the new era, the new trend where we are. So let's talk about generative AI. Why not? Because this is what we normally do. We normally use and maybe high chances you normally we use it, or we might be using one you don't know. So generative AI is something like ChatGPT. Think in that line. ChatGPT, think of it in that line. So this is a type of AI. Grab that word. Generative AI is a type of AI that can create new content. That's the idea. It can create new content like texts, images, audios, video, and even code. Using your ChatGPT, you are able to generate text, very long essay, even a poem. You can able to generate images like the Gemini, they have what's called Nano Banana. You can able to generate image. Like you can say, generate for me image of a peacock. Let me show you something. Let's say Gemini. Okay, so I have my Gemini here. I want to ask it. Let's say generate image of a peacock or a horse. I don't remember that spelling of a peacock. Horse. Let's see what it does. Let's give it some time generating that thing. Wow, there's it. I will see that, Mr. Dennis. Yeah. So I'm able to use generative AI like Gemini for that instance, okay, to generate an image for a house. Long time ago, this will take you a number of time to design. You can come, grab your house, place there, organize these timbers, put some blurry animals, then focus the screen. This will take you huge amount of time. But nowadays, just use generative AI, then you come up with a house. I can take this, download it, put it in my wall. I've given you a business model. You can go to it, just generate image yourself. For those people who don't know how to generate it, then earn something. That will be wonderful. Okay, so we can generate images, text, and audios, and even code. You can write a code to solve a particular task. Now, so all these particular activities mimics a human created output, like what I've just shown you. I would have done that using something like Canva or any sketching tool. I would have used that to design. But nowadays, generative AI can do that kind of task. So it basically represents a fundamental shift from the traditional AI, which only classifies or predicts. Yeah. So instead of just classifying or predicting, I'm able to generate my own, come up, can create. Now, let me tell you a little bit something the comparison between traditional and generative AI. Let me expand it a little bit. Now, we have the comparison between generative traditional and generative AI. This is the current one. This was the oldest version. So let's see what was happening and now what's happening right now. So in the traditional way, we had what's called discriminative classic that is able to classify or predict based on rules. Just pass it rules, it's able to do that. To be able to do that. Now, these rules that are defined in even the machine learning algorithms. Let me tell you something. Uh, Traditional AI algorithms contains even the supervised and unsupervised machine learning algorithms. Then have the modern AI, that's generative AI, okay, like those called the Nano Banana, the Google, the Gemini Nano Banana, or the ChatGPT, that's able to generate text, images, and code, something of that sort. So in the traditional algorithm, you can define a rule like, is this a cat or a dog? After passing your data, you can ask, is this a cat or a dog? Then you can tell you, oh, this is a cat. Why? Because in your rules you gave it, oh, should having small ears, blue eyes, fur, not feathers, fur, okay, not even hair for human being, fur for cats. Why not dog? It's not. The dog is longer. It's normally having black eyes, long ears. Okay, so you can define all those particular rules in that. So I'm able to predict whether it's a cat or a dog, and I'm also able to classify dogs versus cats. Now, this shortfall, they were limited to predefined categories or rules. An example is the spam filters and fraud detection in banks, spam filters in like in email. Now, what about generative AI? This is able to create new things. So, like draw me a cat playing guitar. Draw me draw a cat playing guitar. Let me copy this by the way, why not? And then I'm going to paste it here. Draw a cat playing guitar. So let's see if it will do that. It's doing some work. Let me give it some time. It's doing some cat. Yeah. So I'm having something. Draw me a house playing guitar. Though I told it a cat. Oh, it's based on same context. If I create another one, let me create another one. Sorry, a new chart. I give the same prompt. Draw a cat playing guitar. Let's see if it still confuses with the other one. So you have what's called the context. You have that flow. Context is just like a flow. Maybe it misinterpreted as now. I'm telling it play, do for me that particular horse playing a guitar. So let's watch out this time around whether it's having the thing I desire. Let's see. Yeah, that's it. So I'm having my cat playing guitar. Are you able to see that, Mr. Wilberforce? So I'm able to create this particular kind of things. You can take this, download it, put in your wall. You can do with it anything. You can design stickers from this and sell. You can just view it. You can do with it anything you want. You can download it, copy it, and paste in my document. I can share this to you or any other person. Go try it out. This Gemini, you can try it out to create some images. Anything you want. And then remember that it is this AI ethics. So it won't create for you, okay, something that's not in a Christian way to say. You can't create something undesirable out of this. You can't say that no, create for me someone killing someone. No, it will tell you can't do that. So you have to create something positive, realistic. That's normal. Yeah. So there's that ethics also included. That we will see that in the later section of the course. So, oh, let me. How do I stop that sharing? Or let me share this tab. Let me refresh it. Let me refresh it to see that document. Okay. So there's a bunch of things I want to complete today. Now, example of this is ChatGPT. You know that Cloud AI by Anthropic, DALL-E. This now the Facebook one, Sora. You have a bunch of them like Perplexity, DeepSeek, Gout. Some are not included. Just some few example. I know you definitely have one that I don't know, like what Mr. Wilf was used in the laws in the legal sector. I myself I don't know. I know they have a name for it. Yeah. So that's an example of the generative AI model. So I have a chart here comparing how they're being used by percentage. You see ChatGPT is used more phone, followed by cloud, or the from Anthropic. I'm having the Google Gemini, what I've just used right now. I'm having the Llama for Meta, DeepSeek, the Chinese one, the DALI for images, Sora for videos. And then I have this one called, how is it called? Vio for creating videos. Yeah. You have a new model by Google called Vio for creating videos. I can just create my movie by that. I know that's very interesting. So this is just the chart. I'm just talking about it. ChatGPT was by OpenAI, Cloud is by Anthropic, Gemini is by by Google, Llama by Meta or Facebook, DeepSeek by DeepSeek. Okay, and the key features. So you see, you read that to free time. Yeah. So once that's said, let's talk about what's called RAGs. RAGs. So this is also a key concept in generative AI and modern AI. RAGs. Okay. Now, RAGs known as retrieval augmented generation. Okay. Earlier on, it was called Llama. Okay. Now, LLMs like ChatGPT, they normally use what's called RAGs. We want to generate something. Okay. So now, RAG, let's see what's RAG and why is it needed. So let me tell you something. So RAG basically enhances LLMs like ChatGPT by retrieving relevant information from an external knowledge source before generating a response. What does that mean? Retrieval, augmented generation. I'm going to retrieve, I'm going to augment, I'm going to combine, then I'm going to generate. Okay. Now, let me give a scenario. I was typing a prompt and I'm saying Obama was. Yeah. Listen, I'm typing a prompt to ChatGPT. I'm telling it Obama was. Obama was. Now, leave that point. So when I press enter, what are some of the expected output that what are some of the example output that you might expect, Mr. Dennis? If I say Obama was, what's something that you can expect from that? Definitely, that's correct. Yeah, Obama was the president of the USA. That's true. Me, I can think of okay, Obama was the first black American president. I mean, the black president. Is that true, Mr. Dennis? Yeah. Uh, okay, what else do you think about Mr. Wilberforce if you are here with us? I'm typing Obama was. Exactly. Imagine that's how generative AI works. That's how generative AI works. It will think for you the more if you give the context. Now that's when now context and prompt engineering comes in. Okay? Give the context. You want to talk about Obama as a senator. To give you anything, every relevant information based on Obama as a senator. You want to talk about Obama as a former US president. To give you information based on that. So that's context versus the prompt will give you the exact or desired output based on what you want. So that's an example. So that's the summary of what's called retrieval, augmentation, and generation. I'm going to retrieve information from an external source, maybe some website like Wikipedia or the US government.gov, that particular website. Then I'm going to augment that based on your prompt and context, and then I'm going to generate for you an information. So that idea helps to solve critical limitations like knowledge cutoff, like LLMs like ChatGPT doesn't know about events after its training date. A good example let's use this particular idea is the Perplexity and Grok. By the way, by the way, uh, Elon Musk has a platform. It's an AI company called XAI that came up with Grok. Grok is able to retrieve for you even the Twitter that's posted today. Were you aware of that, Mr. Dennis? Yeah. So it's able to retrieve for you Twitter, a tweet that was posted today. They normally call it today is an X platform, formerly known as Twitter. So it's able to get for you information that says even after its training. Like ChatGPT was trained. The last data was around 2022, up to 2022, from when the internet was created up to 2022. But if you ask it today's date or tomorrow's holiday, I know tomorrow is an holiday for the Islamic community. If you ask it tomorrow's holiday, it will tell you. How will it know that? It's what's called the knowledge cutoff. Another limitation or shortfall is hallucination. So models can confidence generate plausible but false information with confidence. By the way, with confidence, the earlier versions of ChatGPT like 3.5, there are a lot of errors. Lot of errors. Give it a math problem, it will give you wrong answer that it perceived to be correct. Wrong answer that perceived to be correct. Itakugeneratea mathematics solution yenye yeye itajua ni correct. Then you ask, no, it should be this way, it should be this way, should use an equal sign here, should use this particular formula. Then it will be like, oh yeah, yeah, you are right. Should be that way. Or if you experience that, Mr. Wilberforce, you're trying to give an AI question, then you contradict yourself, and then tell you, no, you are now correct. It's that way. Earlier on, were you able to see that, Mr. Wilberforce? Yes, the earlier versions of ChatGPT, like 3.5, you give it a math problem, okay, to give you a plausible or confidence answer, okay. Then you follow up, we give it a follow-up question like, no, in here should be using a square root instead of this, you should be using this particular formula instead of this. Then it will tell you, yes, you're correct, it's that actually that way, and then it's up to recorrect that itself. Were you able to notice that earlier on? What about Mr. Dennis? Those who are in the maths. I know you're in engineering something, I remember. Mr. Dennis. Were you able to notice that? Yeah, exactly. So yeah, it's there actually. It's there. It's there. Exactly. Excellent. So, yeah, yeah. I hope you're able to, to hear that, Mr. Wilberforce. There's that particular notification they tell you no. AI is prone to error. You always should confirm your information with other sources. Yeah. So this that idea of AI as hallucination. The earlier versions, when I was still studying, by then, when I was trying out ChatGPT, because I also did a lot of maths, to give me something I know well. Then if I tell it this is the correct formula, and it will be like, ah, no, you are correct. It should be that way. That will use what you've just tell it and generate a new response. So the other versions do that, but now it has improved. Though there are some remaining limitations, but I know the team is working on that. Again, there's what's called no private data. this this direct. I cannot ask AI what's your Gmail password. They still know that your Gmail data. Remember that, not Gmail data per se, but maybe a website like Wikipedia. It has information about almost everything, include someone's spouse, someone's house, someone's net worth. Maybe, I don't know, the passwords for the bank, but you can't ask AI now. Tell me where currently Donald Trump sleeps right now, or tell me the password for Mr. Wilberforce bank. So it can't share that particular uh, information. It will tell you no, it can't do that. So there's no private data sharing for that particular uh, matter. And there's no citation, cannot tell you where it found the information, because that data is all over. In academia, there's that aspect of duplication. So there's no exact form where that particular thing was found. There's a bunch of websites talking about the same thing. So that's it. Now we have what's called the RAG architecture, what I've just talked about. Okay, let's play around with the remaining 20 minutes. I complete this. Though, as I told you, you'll be able to read this particular thing at your comfort. I might be moving so fast, I know, but you'll be able to do that as well. So, the RAG architecture, we have the user queries. You ask, okay, that. Then your AI will retrieve your information from the knowledge base like document, databases, and websites. So, once you put your query, it will retrieve that information from all over. Not now, not in real time, but though there's those particular models like Perplexity and Grok is able to retrieve that information right now. ChatGPT can do that for the information it is trained on. So it can retrieve that data and then do what's called augmentation. Your query together with the context or your prompt, then you'll have your generation or your output. So that's the architecture of a RAG. I'm able to upload a document, by the way, then ask it based on that particular document. Try this out if you're still studying. Take the entire lecture notes, post it there, take a past paper question, throw it there, and then ask it for answers. It will tell you based on that document. Yeah. Like PDFs, databases, websites, all that. So that's an architecture. We'll be able to see that in details. And that's what I've explained in summary right over there. So, what's the benefit of using the RAG? It provides up-to-date information, like the Grok one, Twitter, up-to-date information. It will also help in reducing hallucination, what Mr. Dennis has just said. There is also what's called a source attribution, or can cite exactly where the information came from. Right now, if I'm writing an article, I can tell it now, set for me that in APA format. It will do that. It will cite that, it will get that information. And you can do what's called domain specific. Like I have that AI that only do mathematical problems. I have that AI that can only do legal matters. Is that okay, Mr. Wilberforce? You have that AI that only do legal matters. Only. The best in that. I have this particular AI that can do medical, I mean health related matters. Okay, uh, I'm very equipped with the AI one. We have what's called Gauth. Gauth is domain specific for solving AI problems. Though we have a number of them, like the today we have even the Quillbot having its own AI for text generation and grammar check. So you can be domain specific. It also helps you what's called cost effective. Like you don't need to retain the entire model from scratch. I can reuse this particular model all over and over again, like what I'm having here. Today I can tell it now, generate for me now this particular cat sitting on the chair. I won't retrain the entire thing over and over again. So there's that aspect of reusability. Yeah. So that's the idea. Is there any question at that point, Tim? Anyone with a question, kindly? Are you comfortable, Mr. Wilberforce? So you have something. Okay. So to Mr. Dennis as well. So let's just know the knowledge on how AI works. So as you'll be using ChatGPT from tomorrow or any other AI model, you should know how it works and how did it came to life, how was it trained. And remember this: we want to create our own AI model. We want to train our own AI model from data. Then from that data, I'll be able to classify and predict. Okay. So for generative AI, let me tell you something. For generative AI, you don't have to retrain the entire data because after all, where will you get the entire internet data? And where will you store it? Nowhere. So we have what's called the what I've just talked about lastly, cost effective. You use it without in training the entire model from scratch. So they give you what's called API keys for you to their models. I can use API key for ChatGPT. So I'm going to fine tune it so that to let me solve only agricultural problems. Okay, I'm going to use the API key. What I mean, I'm going to use the model themselves to work on only agricultural problems. You, Mr. Dennis, can use it to define your own AI for engineering solutions, maybe coming up with designs. Instead of you relying on the CAD or any other design software like AutoCAD, I mean, you can use a ChatGPT API, the premium versions, to come up with your own AI model that can help you in doing what's called designing, or with coming up with quotes when you want to build your house, price and material quotes. Yeah, anything, any field. Yeah. So how does AI works and how is it trained? How did these people come up with AI like ChatGPT? That's what we want to do. What we want to learn about. So there's this step by step on how AI is. Okay, how is it trained or how does it works? What is the original? What is the steps for coming up with your own AI? What are the steps for you to come up with your own AI? So they have the training workflow. The first thing you have to do, you have to collect data. You have to collect data. Where you're going to train your AI. So we have this particular CEO is called Alexander Wang. It rules define data as the new oil. Data is the new oil. Leave about the oil that's now we're facing in the global right now. Data is the new oil for running the AI industry. So if you have that data, you're rich. You are rich. So data is the new oil that will fuel the AI industry. That's how we define it. So you have to collect your data where you want to train your AI. The data must be accurate, okay, curated. They call it curated data. Don't mix up things. Label your data correctly. If it's a cat, give them cats. If they're dogs, give them dogs. If they are bottles, label them bottles. You have to curate that particular data. Sell it. You learn some money. You'll be rich. So it's the new oil, as that particular guy defined it. So the first thing you have to collect your data. Remember that. First, you have your own data. I'm going to share with you that we're going to work with. Then we want to do what's called data preparation. You remember what we did in data preparation earlier on? We did data preparation. So here we want to do what's called data preparation. So collecting data here, we get raw data either from secondary or primary sources. And remember the hack is the more the amount of data you have, the more the accurate your model is. If you have few data, to be limited to your few data. If you have millions of data, your AI will be accurate. Think of it as a probability. If you have more chances, the probability score will be high. Yeah. So data preparation here will involve cleaning that data, labeling that data, then do what's called you train and test. You split it in what's called a training set and a testing set. You want to do that in a few. The next thing, you want to choose your model. How do you choose a model? Based on the type of task you want to do. Okay? If you do a classification problem, which algorithm are you going to choose? Can I something like a addition to classifier or a random forest classifier? If I do a regression analysis, which algorithm should I choose? According to like a linear regression. Okay? If I do a prediction algorithm, which one should I take? You choose your model based on the type of task you want to do. The next thing, you want to train your AI model. You want to train our own AI model in this particular class. You will train your entire AI model based on your data to learn from the patterns from the data. Then you're going to do the prediction or classification based on the task you want to do. Now, after training your data, you're training your AI, you have to evaluate it. The accuracy for your AI, you have to evaluate it. The accuracy of your AI. Here's when we talk about things like precision recall function and what's called F1 scores. So some of the algorithms for evaluating AI are like when we talk about these are now some mathematical terms. Don't worry about that. I'll clear up everything when that time comes. We have what's called precision recall function and F1 scores. Another one is called the MCA, mean squared error. So we have various ways of evaluating the accuracy of your AI. You can check the weights of the graph, you can check the accuracy in type of percentage. You can do that directly. You can compare the precision and the recall function using the F1 score. F1 score is now the ratio between the precision versus the recall function. And also go to check at what's called the loss function. Don't worry about everything, we'll get that into details when that time comes. The good thing, when that time comes, I'll explain everything into details. Then the last thing you want to do is you deploy your machine learning. Deploy it, tell users how to use it. I built a machine learning algorithm to predict for me a house price. I'll give you, try it out. I'll give Mr. Wilbur to try it out. Give it entries to predict for you a house price. If I'm in Nairobi, it will no. I'm living in Nairobi. I want a two-bedroom house, permanent story building. Okay, it's based in Rwanda. So tell me that they give me the price for that particular type of house. It's based in Rwanda. Remember, not the slums. It's a two-bedroom house for a story building. Okay, it has this a number of amenities like swimming pool, gym, all that. It's already there. So tell me the price of that particular house. My AI will be able to predict for you that particular thing based on the data I have given it. Maybe I can say, oh, all houses in high-end places like Kilimani, Runda, Westlands, they range from maybe 25,000 to 100 plus. Okay, if it's a two-bedroom house with the gym, with all those amenities, with the water availability, access to roads, so just give me the price to predict for me the price. That's the workflow, that's the life cycle of you coming up with your own AI. Collect that data, prepare it, choose the model, train that data, evaluate the scores or the accuracy, then you deploy it. You want to see how to deploy that. So we've got the neural network and how it works. Like the human brain, how does it work? The deep learning algorithm. So you have the input layers, the hidden layers, then we're going to get the output layer. So don't worry about that. So there are this particular few concepts in AI that we can't forget to talk about. Epochs, batch, loss function, optimizers, learning rate, backpropagation, and gradient descent. I believe they're sounding like huge things for now. Now, epochs, just now, one complete training you call an epochs. They normally be from 10. I normally use 10 epochs or iteration. One complete entire life cycle for training a data set is called an epochs. So, batch is now the division or the subset of my data for processing. Loss function is the error. Okay, loss function is the error. Like if I have my accuracy to be 85%, I mean my loss function can be 15% because I've not achieved 100% uh, accuracy. So loss function is now the error, or it measures how wrong the model's predictions are. During training, you will see the batch, you will see the epochs, and you see the loss function being displayed. So by seeing your loss function, you're able to see, is my AI doing well? Is my training going well? Or what should I do? Then now where you can call us call now optimizers. Optimizers. So we have some particular optimizer like Adams and SGD. Adams and SGD. So basically Adams helps to adjust the weights to minimize the what? The loss function. You can adjust your values. You can check the parameters. You can say now just do two epochs to avoid what's called overfitting. That's going to talk about what's called overfitting and underfitting a model. Okay, don't talk about that. We'll see that how it's done. Like think of you studying for an examination, then you have crammed your notes. You have crammed your notes. You want to sit for an examination, then you have crammed your notes. What does that mean? You will only answer question that's based on your notes. Is that true, Mr. Dennis? Yeah. You've only answered questions based on what's then your notes because you crammed them. Out of that particular individual is studying in a smart way or in a hard way. So we have to study leveraging both from other sources, past papers, lecture notes, articles, videos. Don't give it any question. This particular student will definitely pass. Whether you take any unseen question anywhere, you'll be able to apply and pass. And then you have person A who is just cramming the notes. If you give it the notes, it will get 100%. Let me tell you, someone who has crammed the notes would give you 100% score. That person who has been studying, leveraging both sides, will get even 80% of the score. So look at this particular individual. One has crammed the notes, one has studied general. This person who has studied the exam general will always pass. Why? Whether it's from the notes, whether it's from the articles, it's from anywhere. Any foreign material will be able to apply that and pass the examination. This particular student who was crammed, okay, can score 100% in that particular test. Now, that's what's an example of what's called model overfitting. Not a good idea. Not a good idea. Model overfitting. So if you give it a foreign or unseen data, it will give you zero score. For someone who has cram, give any question anywhere. Just apply a question, give it will score a zero or even 1% for just sympathy. So in training your AI model, you have to consider that you have to see you avoid what's called model overfitting and underfitting by checking at what's called the loss functions. Okay, so for you to do that, what's called now back propagation to take the error backwards. Error is done the loss function. How do you minimize the loss function? And how do you update the weights? The weights itself will help you to do what? To help to minimize the loss function. Like in Adams optimizer, you can take back the weight itself, maybe from 10 to 5. This what's going we here we want to talk about what's called hyperparameter optimization or hyperparameter tuning. We want to work with our parameters. The last thing we want to talk about is called gradient descent. So this is now an optimization techniques to find the minimum of the loss function. Just following up that point, I have a chart here. I have a chart here. How common these particular algorithms are being used, like linear regression, decision tree, deep learning, and currently of ChatGPT. ChatGPT is now the where we are. Normally, people use large language models (LLMs) like ChatGPT in the recent days. Okay, you have to grow with that particular aspect. So we have deep learning, like those who are using self-driving cars, you can do that. Decision tree classifiers, you can write your own model to do that. Linear regression, you can do that. Even in Excel, you can do a linear regression in Excel to do that for you. But there, I saw something I was almost forgetting. Tokens. Tokens now the basic unit of identifier data or chunks. Call it tokens. And this is what they use for their business model to get money. Based on the tokens, you may sometimes use ChatGPT until you know stop. It will refresh after 8 hours or maybe tomorrow 8 a.m. because you've completed all your tokens. Yeah. So that's it for that. Tomorrow I'll complete AI ethics. It's a very brief concept. When everyone will be there, then we'll start writing our own AI models. Because of the interest of time, I see we are already done, but it's quite a number here. I don't want to consume too much time. Yeah. So tomorrow, let's complete on AI ethics. Okay, it's a very interesting concept that you don't forget. We'll discuss that when everyone will be there, and we start writing our own AI models from supervised machine learning, then we move to unsupervised, then we move to reinforcement together the neural networks. Get our own data. We have collected our own data. We want to prepare that data. We want to train that data. We want to evaluate the accuracy. We want to deploy it. So that's the life cycle we'll be doing in the remaining parts of the course. Unless there's any question from anyone, I don't want to consume much of your time. I've really talked so much. Hello, Mr. Dennis. Do you have any question? Okay. What about Mr. Wilberforce? Do you have any question? I've said a lot. I think she'll be having any question. She'll be having a question. All right. If there's no question, I said the class is being recorded. I'll take this particular video. I'll upload to YouTube. I'll share with you the link. Then you will be able to listen to that. If you find something not clear, just scroll back Okay. I know some at some particular point I was fast. Just scroll back, listen, and then you get there, whatever thing I was talking about. I think that would be a good idea.